Good day, everyone. I'm Dr. Prasetyo, an associate professor in School of Industrial Engineering and Engineering Management, Mapua University. I'm going to present my paper with title Utilization of Color Similarity Index for Evaluating Existing Military Camouflage Designs. This is the agenda of my presentation. So I'm going to start with introduction, continue with methods, results and discussion, and also conclusions, limitations, and future research. Introduction. Introduction in here, I'm going to present about the importance of the military camouflage in the industry. Military camouflage is a million billion industry. For this design, it costs perhaps more than 100 US dollar. So definitely military camouflage is a million billion industry. Military camouflage is an important part of combat uniform. It is an attempt to minimize the difference between the Army combat uniform and the surrounding background. Military research organizations worldwide are continually engaged to maximize the concealment of the camouflage because it can enhance the survival ability of the frontline soldiers. There are many studies about the military camouflage. For example, this study tried to construct or generate the new color and pattern based on the selected background. And the result is quite amazing because in here we can see that it's actually the concealment is actually pretty good. However, this study is actually very difficult to be implemented in the military research organizations because each military organization they have they their own standard, their own color, their own identity. So constructing a new military camouflage color and pattern is definitely very difficult to be implemented in a real world. So why don't we analyze the existing military camouflage using the existing algorithm? So that's why I conduct my study. Previously, Lin et al. 2014 developed a Camouflage Similarity Index, or they call it CSI. CSI, the algorithm, the value range from 0 to 1. When the value is 0, is perfectly blended. It means that the camouflage and the background is perfectly blended. But if the value is 1, it's actually totally different. So that's actually the logic between 0 to 1. So for example, on the left side in here is actually the camouflage, and on the right side is actually the background. But the CSI in here, the logic, it has to be 20 to 50 pixels. And after that, this is also the same 20 to 50 pixels. And they try to run this one in a MATLAB, and we get the number, the CSI value. So the CSI, definitely the lower the better. And Lin et al. 2014 also proved that CSI and detection time is actually significantly correlated, but the correlation is around 0.436. This is my past publications related to the military camouflage assessment. In 2019, I published one STI paper in color research and application. And this study is actually I utilize response surface methodology. It's a new practical approach for enhancing a selected military camouflage, a real military camouflage. And from that one, I developed a more advanced optimization approach. I utilize the meta-heuristic methods using the particle swarm optimization, and I could produce even lower CSI. And also, I've published several simple studies. For example, in the International Conference on Industrial and Business Engineering, in here I analyzed the China military camouflage designs The same using the camouflage similarity index, but in here, I apply the CSI to evaluate the existing military cameras, the real one. But the previous two SCI publications is actually I tried to develop a new significant and practical approach for enhancing a military camouflage. And I also published one in Malaysian Journal of Public Health Medicine. It's going to be published soon. In here, I utilize CSI to evaluate Southeast Asian military camouflage. So in here, actually from China, and I moved to the Southeast Asian military camouflage. And what about this study? This study, I combined so many different countries. So using the same approach with a CSI and with a simple statistical analysis, then I would like to see is there a significant difference between the selected uh, military camouflage? I mean, in terms of the CSI, is there a significant difference? We will see. And CSI is actually uh, utilize the CIA LAB color space. What is CIA LAB color space? Okay, for each color, they have their own LAB value. It's actually in three-dimensional color space. So for example, the green in here in this camouflage. Oh, this camouflage actually has four different colors: green, khaki green, gray, and black. And for each color, it has it owns the LAB values. So for example, in here, the green is actually 26, -7, and 6. So this is why this color is actually different because the LAB itself is actually different. But in order to calculate the CSI, we need to make this dimension into the overall. Because if we cut into like this, we can get four different colors, yes. But in a MATLAB, we need to transpose from this dimension, like 4 times 3 into just 1 times 3. So that is actually how the CSI works. So we compute the overall of the LAB. So that's why we got the value with the decimal value in here. So the objective and contribution of this study. The purpose of this study was to apply a color similarity index for evaluating existing military camouflage designs. And this study contributed to the advancement of color similarity index to the existing military camouflage, and the results would be very useful for military research organizations, Ministry of Defense, and textile engineer. So simply, I utilize the color similarity index to evaluate the existing military camouflage, and perhaps can be the basis for advancements of that military camouflage. Methodology. As I've mentioned before, that I will utilize the CSI to evaluate the existing military camouflage. So how can I do that? First, I have to get the camouflage itself. Since I don't have the access with the military organizations worldwide, I utilize Google search engine. From this Google search engine, for example, in here, I get this picture and I cut one location. It's actually around here, and then it's actually this one. So this is actually the 20 times 50 pixels. So this is gonna be one design. And then for what about for the background? In the background, I followed with my previous my four previous studies. It's actually I utilized this woodland background. But from this woodland background, it's actually I choose 14 different locations. The same, 20 to 50 pixels. So I pick up 14 different locations. Why is that? Because I would like to evaluate that camouflage in a different uh, with the background with the different LAB colors. For example, in here is a little bit dark, in here is a little bit bright, in here is a bit white. So I would like to see how how this camouflage works in those backgrounds. And I would like to take the average of the CSI for each location in here. So, okay, 14 backgrounds or locations in here. So after I cut into 20 to 50, 20 to 50, and everything in here is actually has done been, I utilize MATLAB, and after that I will get the CSI value, and then I would like to run the statistical analysis whether it's significantly different with other designs or not. Results and discussion. So this is actually uh, 10 different camouflage that I use. This is actually just the name. I just give the name A, B, C, I, J, M, P, S, S, K, and T. And I evaluated all of this camouflage uh, in these 14 different backgrounds. So this is actually the overall LAB for this design. As I mentioned before, I have to run the overall LAB for each design, including the background also. So how it works, for example, like from A, I evaluated this camouflage in the location 1, 2, 3 up until 14. B, the same, repeat until the T from location 1 to location 14. So this is actually the result. Okay, so S is actually has the lowest average CSI in those 14 different locations with the value 0.8005. So this is actually good in terms of the overall. And it's actually the T is actually uh, it has the highest CSI with the value 0.9119. So this design is actually need more adjustment. However, even this is the highest CSI, but look at this design in that location, in the location 3 and location 4. It it's found that it's actually this design had the lowest in these two locations. So it means that the design is actually pretty good for this dark location. So it could perhaps in the evening. And SK is good for location 2, and then P is good for location 9, and then A is actually good for location 1 and also location 14. So, although this is the lowest, but it's actually other design is actually good in several different locations. So to make it fair, I run the statistical analysis. Is there a significant difference between each design? Oh, before that, then I gonna explain this one first. So look at this. This is actually pretty obvious, right? This color with you tested in these 14 different locations, so it's gonna be like got around that. That's the average, and this is actually pretty dark. So if you run in these different locations, 14 different locations, it's actually pretty good in only location 3 and 4, but it's actually pretty bad in other locations. So with our eyes, it's actually pretty obvious that actually this is actually not a good one. However, this is actually very unique. Although S had the lowest CSI and a T has the highest CSI, however, there is no significant difference. So what's that mean? So it means that each design has the same level of concealment. Yes, it is different. The CSI is different, but the difference is actually not significant. But I only found that the significant difference is actually only this one, only S compared with the BCIT, but the rest is actually pretty not significant. But in terms of the overall, it's not significant. Conclusions, limitations, and future research. So Uh, for the conclusions, the first, most of the existing military camouflage were found to have similar level of concealment in the selected 14 backgrounds or 14 locations because the CSI is actually not significant different, right? And was found to have the lowest CSI value. And yes, as I've mentioned before, statistically no significant difference in terms of CSI value. And for the limitations, the of course the first one is going to be the lack of proper military camouflage collection because I only utilize the Google to collect the camouflage itself. So in the future, the future research, if I can get real military camouflage, then definitely it will be better. Just like my two previous SEI publications, it is actually the real military camouflage. But in this study, I don't have the access to do that. And the second limitation is actually the CSI values were limited to the selected woodland background, which was taken at 9 a.m. So if you change, for instance, that the background is actually a little bit dark in the evening, of course, it will it will lead to the different LAB value, which subsequently lead to the different the CSI value. So if you change the background, of course, the result will be different. So that's actually the limitations of this study. Thank you. So that is my paper. I hope you enjoy. Thank you, everyone.